Hey everyone, this is part 7 of the SHSAT 2019-2020 math section, and we're starting at question 100. So let's get started. So we have a certain square puzzle which has an area of 64 square inches and a cubic block which has a volume of 64 cubic inches. And we want to know what the ratio is of the length of a side of the puzzle to the length of a side of the block. Okay, so we have the puzzle being square, right? So we can sort of say like this is our puzzle. And then we have a cubic block with a volume, right? So this is, I'm pretty bad at drawing 3D. Let's see. Yeah, so we have a slanted 3D block. So anyway, this is our block, right? So the point, I guess, here is that our puzzle is two-dimensional, right? Whereas this block is a cube and it's three-dimensional. So now that we have drawn these, we see that both of their areas are 64 cubic inches, and we want to basically know the ratios of their lengths. So I'm going to call the length of the square puzzle x and a length of the block as y. So we know that for like a square, its area is just going to be its length squared, so that's x squared. And we know that its area is 64, and therefore x is equal to 8. So that's one thing. And then for our block, we're going to do y cubed to find the area, right? Basically, its length times its width times its height, but all of them are y, so it's just going to be y cubed. And that's also equal to 64 because that's its area. So then y would be equal to the cube root of 64, which would just be 4. So y is equal to 4, x is equal to 8. And we want to know what the ratio is of the length of a side of a puzzle. So let me clear up some space here. Okay, so the ratio of the length of a side of the puzzle, which is 8, to the length of a side of the block, which is 4. So this is our ratio, but we have to simplify it. So let's divide both sides by 4. So this would be 2 to 1, right? That's equivalent ratio. So yeah, that would be our answer, 2 to 1. So that's 100. Okay, so now on to 101. So in a certain class, Rosa will take a total of 4 tests. She has already taken 2 of the tests and earned scores of 81 and 83. And we want to know what the least possible score Rosa can earn on the 3rd test and still be able to finish the class with an average score of 85 on all 4 tests. Okay, so let's map out our tests here. Okay, so for the first 2 tests, she scored 81 and 83. This is sort of our mystery test, right? Because we're being asked what the least possible score that Rose can earn on the 3rd test. Yeah, so 3rd test, and still be able to finish the class with an average of 85. So I'll put this here, average is 85. So if this 3rd test, if she's scoring really low on the 3rd test, then we want her to score the highest she possibly can on the 4th test, because scoring really high on the 4th test will allow her to score the lowest on the 3rd test while still maintaining this 85 average, right? So we want the maximum possible score on the 4th test. Now this just becomes a question of solving for this question mark. So I'm going to clear up some space. Okay. So I want the average of these 4 tests to be an 85. So therefore 81 plus 83 plus question mark plus 100 over 4 is equal to 85. We're going to do this work over here. So now I multiply both sides by 4 to get rid of that 4 in the fraction. So we have 81 plus 83 plus our 100 plus question mark is equal to 85 times 4. So if we add these together, this is going to be 264 plus our question mark is equal to 320 plus 20, which is 340. So then our question mark is going to be 76. So that would be A. Okay. Excellent. So the idea with 101 was that if we want Rosa to do as poor, well, this is a horrible way of putting it, but if we want Rosa to do as poorly as possible on the 3rd test, then she needs to get the highest possible grade on the 4th test. And then, yeah, we just need to solve for this quote-unquote bad score on the 3rd test. Okay. So 102, the Barnes family and the Ramirez family each have a pizza of equal size. The first pizza is cut into 18 equal slices, and the second is cut into 15 equal slices. Okay, so I'm just gonna, so we have Barnes. Now Barnes's pizza is cut into 18 slices, and then equal slices, and then Ramirez pizza is cut into 15 equal slices. Now the Barnes family eats 11 slices from the first pizza. What is the greatest number of whole slices from the second pizza that the Ramirez family can eat without eating a greater percentage of a pizza than the Barnes family? Okay, so basically, the Barnes family is eating 11 out of 18 of their slices. And then the Ramirez family is eating some amount of slices over 15, right? So these are sort of fractions. And we basically want to know, so what's the greatest number of whole slices from the second pizza that Ramirez family can eat without eating a greater percentage? So basically 11 over 18 needs to be greater than this question mark over 15, right? Because this question mark needs to be as big as possible without making the fraction greater than 11 over 18. That's basically what this word problem is saying, right? Because without eating a greater percentage. Because if Ramirez eats too many slices, then they're going to have a greater percentage of pizza than the Barnes family. So anyway, this is our inequality. And now we need to solve for our question mark, which is the number of slices that the Ramirez family eats. So to do that, I'm going to multiply both sides by 15. Okay, on the right side, these cancel out. Now on the left side, I'm dividing both sides by 3 basically, so I get 5. Here I get 6. Okay, so now I'm going to rewrite this. So 5 times 11 is 55 over 6, and that must be greater than our question mark. Okay, now 55 over 6, that's, so we know 54 over 6 is 9. So in other words, question mark is less than 55 over 6. And so 54 over 6 is 9. So we can write this as 9 and 1 over 6. So our question mark needs to be less than 9 and 1/6. but we want our question mark to be as great as possible, right? Because the greatest number of whole slices. So let me clear up some space here. So if we want our question mark to be as great as possible, and it needs to be an integer, right? Because you can only eat like a whole number of slices. You can't eat a fractional amount. So then the question mark must be equal to 9, right? Because if the question mark was equal to 10, then 10 is not less than 9 1/6. But if the question mark was 8, then we could increase the number of slices to 9 and still be less than 9 1/6. So 9 is the right answer. Okay. So now we're going to go up. Okay, so 103 is our next question. So basically 103 involves what it looks like is exponents. So we have this expression above, and we want to know what its value is in decimal form. Okay, so basically we have this expression, and order of operations dictates that we evaluate the exponents first and then add them together. So I'm going to start with 0 cubed. So 0 cubed is just 0 times 0 times 0, which is going to be 0. And then plus 4 to the 0. So basically anything or almost anything to the 0th power is just 1. So 4 to the 0 is 1. Now 2 to the negative 1, this is just 1/2, right? So we have plus 1/2. And then negative 1 squared, that's going to be negative 1 times negative 1, which is just 1. So finally plus 1. Okay, so now we have a simpler expression, and now we need to add this together. So 1 plus 1 is 2, plus 1/2 is 2.5. So, and now we want this in decimal form, right? So that would be 2.5. So that would be D. Okay. Alright, so 104. A company wants to study 6 brands of soap by comparing each brand with every other brand. If each comparison costs $2,000, how much will the company spend altogether? Okay, so basically we have 6 brands of soap, and we want to compare each brand with every other brand. So first I want the number of comparisons. So forget about the cost for a second. I just want the number of comparisons. So basically, the number of comparisons in this case is just, well, I don't know if you guys have learned about like this notation. So this would be 6 choose 2, but I'm going to assume that you haven't. So basically we have our 6 brands of soap, right? And we want to make a comparison with each and every brand with each other. So this is like one comparison here. And so basically if we have 6 soaps, they're being compared, each one of them is being compared with 5 other soaps. So this is like the number of orderings, right? So if this is sort of our first soap that's being compared, and this is our second soap, then these comparisons can be represented in this way. And there are 6 possibilities for the first soap, and then 5 possibilities for the second, right? Because the second soap can't be the first. But we have to divide by 2, and the reason for this is, let's say you were to swap the first soap and the second soap that's being compared. Well, you would still have like the same comparison, right? It doesn't matter really what order you're comparing them in. And so that's why we have to divide by 2, because we're double counting the number of comparisons. So the number of comparisons would therefore be 15. So, and then we're being asked for the total cost, or how much the company would spend. So if there are 15 comparisons and each comparison costs $2,000, then the cost would be 15 times 2,000, and that would just be 30, and then add the 3 zeros, so that's $30,000, and that would be G. Yeah. Okay, so 105, what number is halfway between 1 over 20 and 1 over 10 on the number line? Okay, so let's draw our number line. This is, say, 0. This is 1 over 10. And maybe this is 1 over 20. Right, and this might be the halfway point. So to get that halfway point, that's basically the same thing as taking the average between 1 over 20 and 1 over 10. Right? If we take the average of those two numbers, we're going to get the number in between. So to take the average of two numbers, we just add them together and then divide by 2. So first we're going to do this addition. So 1 over 10 can be rewritten as 2 over 20. And then this would just be 3 over, sorry, this is 1 over 20. So this would just be 3 over 20 and then over 2, which can be rewritten like that. And then we would have 3 over 20 and then times 1 over 2, which is just 3 over 40. So that would be the average, and therefore 3 over 40 is halfway between 1 over 20 and 1 over 10. So that's D. Okay. Yeah. So a rectangular swimming pool of uniform depth is 20 yards long and 14 yards wide, and the water is 6 feet deep. So we want to know the volume of the water in the pool. Okay, so basically the rectangular swimming pool can be represented as a cube, right? Because we have our length, so we have our length here, our width here, and then a depth of 6 feet. Okay, so this depth dimension is 6, the length is 20, and then the width is 14, and this is all in yards. And we want to know the volume of water in the pool, right? So we have this water that fills the pool, and we want to know its volume. So the volume of a cube, of a three-dimensional like cubic, it's not a cube, but it's like it's three-dimensional. So we just take each of the dimensions and we multiply them together. And yards here is a unit, so don't confuse it as like a variable. So I'm just gonna omit it for now. So 6 times 20 is 120 times 14, and then 12 times 14 is 168, and then I just add that 0, and that's in cubic yards. So the volume in cubic yards is going to be answer choice H, right? Okay. Let's see, and I will continue 107 in the next video.